and out. All right, so I'm going to start a little review here, kind of down in the middle. I'm going to start with number 3. So I have int sample 10, and I put 10 numbers into it. If x equals sample 1, then what's the value of x? Not 4? Again, index for an array starts at 0, so this one would be sample 0, this one would be sample 1. So sample 1 would be negative 1. How about sample 5? 0, 1, 2, 3, 4, 5. That one looks like 2. Sample 9? Negative 8, because that would be the last one. Sample 9 would be the last one since there's 10 things in there. Or you could count it out. That's negative 8. 12, and how'd you get 12? Did math. 1 times 12 is 12, because sample 4 would be 0, 1, 2, 3, 4. That would be 1. And sample 6 would be 2 later. So this would be 1 times 12, which is 12. So again, be careful of that. Make sure when you're dealing with arrays and you're counting that you always count starting at 0. Always need to count starting at 0. All right, 4 we talked about a little bit the other day. 5, arrays and functions. When you pass an array to a function, you pass the memory location. And again, I think I talked about this the other day. So if you change the values of the function, if you change the values of the array in the function, it will change it back in the main. In other words, an array is always a what kind of parameter? Reference. An array is always a reference parameter. There's no options on that. If you change an array in a function, it changes it back in the main. So watch out for that. Sometimes you want that, sometimes you don't. When you refer to an array in a function call, use the variable name only. Don't put the square brackets, and we'll do an example of that here in just a few minutes. All right, so we're going to create a short program here. We're going to create a program that will input 5 values to an array, output the values of the array, double each value of the array, and then output the new array. And then it says, note, there are no aggregate operators on an array in C++. What the heck does that mean? Yeah. Yeah. Correct. There's no way to double all the numbers at once. I can't do just 2 times my array and have it double all the numbers at once. That would be an aggregate function. Unfortunately, that doesn't work in C. It does work in different languages. It doesn't work in C. So if you want to double all the values of an array, what do you have to do? You got to call each value, double it, and then restore it back into the array, unfortunately. Fun, yeah. All right, so anyway, we're going to make a program that will input 5 values to an array, output the values of the array, we'll double everything in the array, and then again output the new array. So I see something here. I see that I want to output the array once, and I want to output the array twice. So that tells me I might want to do what? But then I wouldn't be following directions, because the directions clearly say double each value in the array. So I want to output it first, then double it, then output it again. But here's what I'm thinking. If I have to do output twice, make it a function. That way I don't have to write the code for outputting twice. I only need to write it once. So I think we're going to write a function to do output in this program, to print our array. Okay. Turn the screen back on. It works better. Alright, oh, I didn't do all the stuff I should have done. Let's see, include IO stream. I did forget the hashtag. That's not a hashtag. There it is over there. What's that?
The hashtag includes. It's been a long.
Better?
Yes. No, he spelled
Are you sure it's not Monday?
I'd like to claim there's a bad glare on the screen. There really is, but it's lousy typing skills. Whitehall? All right. So I got the shell stuff that we needed. Okay, so it says input 5 values to an array. So I need to make an array. What kind of values are we going to put in an array? Integers or floats or doubles, one of those. I'm going to go integers because integers are easier to type when I got to type stuff in. So I'll do integers. What do we want to call our array? Values. And how do we tell the computer that this is an array that's going to hold 5 values? What kind of brackets? Square brackets. All right, so there's how we define an array. To define an array, you need 3 things: variable type, variable name, and then how big the array is. Cout. Enter 5 values, 5 integer values. Just a little directions to the user. All right, and then what do I need in order to be able to enter values, the 5 values? I'm going to need a for loop. I'm going to have to do a for loop that goes from 0 to 4 or 0 to less than 5. You can say it either way. Both work. And I'm going to have to do a cin for each value in the array separately. All right, so we need a for loop. For int loop equals 0, loop less than 5, I guess, loop plus plus, cin. What am I cinning? Values at loop. So the first time the loop runs, I'll input a number and do value at 0. The second time, value at 1, value at 2, so on and so forth. All right, so there's how we enter 5 values into an array. So now we want to print that array, it said. And we decided we were going to make a function for that, right? So I guess I got to come back here and make a function. What kind of function is this going to be? Void, because all it's going to do is print. All right, void. What do we want to call it? Output. Do we have to send it any variables? Yes, what variables do we need to send it? We need to send it the array, don't we? So that's int type. And then I need a name. I'm going to be lazy and I'm going to use ARR. And then last time we saw when we passed an array, it didn't matter what the size was. Even if we put size 3 here and then we passed an array of size 5, it still went through. So normally you just tell it you're passing an array. You don't even bother telling it what size it's going to be. And then you can pass any size array you want to. Because we can pass any size array we want to anyway. So typically you don't give it a size there. Does it hurt to put 5 there and tell it there's going to be 5 values? Doesn't hurt at all, but we don't need it. All right, so come down here, void output, int array. Okay. So what do I need inside my function to be able to print the 5 values? Another for loop. I'm going to have to do a for loop to do each one individually. So for int, I guess I'll use count this time. Count starts at 0. Count goes less than 5. Count plus plus. See out. All right, what do I want to see out? R at count. All right, now the question is, do I want them to print across the screen, or do I want them to print up and down? Across. So I should just put some spacing in here. Oop, we said across, not up and down. And then I think after that loop runs, I'll put an end line just so that whatever prints next comes down on the next line, just to make sure. Okay, so there's our function that will output for us. How do I call that function to make it run? I write the word output, spell it correctly, and what am I going to send to it? I'm going to send the variable values, and again, I only put the variable name there. I do not put the square bracket, and I do not put the 5. When you send something to a function, you simply send the variable name. In this case, the variable name is values. All right, so that does the first half. That allows us to enter 5 values and print them. Next it says double all the values. We need another for loop. Again, we can't just, it would be really nice if we could do this. Values equals values times 2. And that's what I would mean when I say an aggregate function, where that would just double all the values in the array. Unfortunately, C doesn't allow you to do that. There's no global doubling. You've got to do each one individually. Like I say, there are other languages that do allow you to do that. If you have an array, you can double everything just like that. You can't do it in C. So unfortunately, to do it in C, we have to make a loop. So I guess it's another for loop. What goes inside my for loop? Need another counter? I can just use loop again. As long as I tell it to restart at 0.
But it's not declared.
That's right. See, loop is not declared. Loop is only declared inside this for function. So maybe it would have been a better idea, since I'm going to need it twice, to define it up here. And then I can use it there again. So int loop starts at 0, loop less than 5, loop plus plus. Value bracket loop equals two times value bracket loop. It's values, isn't it? Yeah, I'm missing an S. That's why it's underlined. We called it values, not value. All right, so that should double it. So what it's going to do, value 0 is going to double it and then store it to value 0. value 1, it will double it, store it to value 1, so on and so forth. Output values. Yes. All right. Well, let's see if it works. Thinking. Enter 5 integer values. 7. 7. No, you gotta have something. 42. 3.
99.
99.
Oh, it's not bad.
21.
That's 5. All right, so if we did everything right, it should print those numbers exactly for us again, and then it should double all those numbers and print it for us again. 7, 7, 42, 3, 99, and then it doubled them, 14, 14, 84, 6, 198. Forward. Questions on that? All right, next it says in the directions, create a function in the above program that will sort the elements from lowest to highest. Sounds like a lot of fun. I'm glad you agree. All right, so before we write the code, we got to talk about how do you sort. Switch the button back there.
Switch your inputs. You sort that.
All right, so here's what we're going to do. We're going to use a sorting algorithm that is very inefficient, but pretty easy to code. Good algorithm for short lists. If you have a long list of numbers, this is not the way you would want to go because it takes too long to run. So I'm going to write down 5 numbers here. 3, 2, 0, 7, 3. Okay. So we want to put those in order. So what order should they be in? 0, 2, 3, 3, 7 should be our final answer, right? So here's what we're going to do. Here's how we're going to sort. We're going to look at this number first. We're going to start here. We're going to compare it to that number. So if I take a 3 and a 2, which number is smaller? The 2 is smaller. So I'm going to switch the 2 and the 3. So I'm going to put the 2 here, then the 3, then the 0, then the 7, then the 3. Now I'm going to take this number 2 and compare it to that number 0. Which one is smaller? 0. So I switch again, don't I? So next I'll have 0, 3, 2, 7, 3. Then I'll take 0 and I'll compare it to the next position. Which one's smaller? 0, so I don't switch them, do I? And then I take 0 and I compare it to the 3. Which one's smaller? 0, so I don't switch them. So basically, what did we do? I used a for loop and an if statement to find the smallest number in the list and put it first. Then we're going to move to the next position. This is a 3. I compare it to this spot. Which one's smaller? 2. So what do? Switch them. So the 0 is not going to change anymore. I'm going to switch the 2 and the 3, and everything else stays the same. Then I compare the 2 and the 7. 2 is smaller, so it's fine. Then I compare the 2 with the 3. The 2 is smaller, so everything's fine. So I found the smallest number, I put it first. I found the second smallest number, I put it second. Then what do? I go to the third number. I compare the 3 and the 7. Which one's smaller? 3, so I don't do anything. I compare the 3 and the 3. Which one's smaller? They're the same, so do I need to switch them? No, I don't switch them. Finally, I go to this position. I compare the 7 and the 3. Which one's smaller? The 3, so I would switch them. What's that?
I have a question.
Go ahead.
Why did the 3 and the 2 go back in the third row? Is that just a mistake or is that really what it does?
That's really what it's going to do.
It really switches the 3 and the 2 back to their original places from the first one. But then the second one, you move 2 up above the 3, and the third one, 3 is in front of the 2 again.
Okay, so what happens is I start at this position and I compare with that one. So 2 is smaller than 3, so I flip the 2 and the 3. So I flip the 2 and the 3. Then I take this first position. I'm still staying in the first position. So I took first and second and checked them, and I had to do a switch. Then I take first position and third position and I check them. Which one's smaller? The 0. So I flip the 0 into 2. I'm not changing the 3 at all anymore. Right, I really changed the 0 into 2. I didn't touch the 3 at all. And then I compared the 0 into 7. 0 was in the right spot. 0 into 3, 0 was in the right spot. So I didn't do anything there. Once I get the 0 in the right spot, then I look at this position. So I'm forgetting about the 0 now. I'm looking here. 3 and 2, which one's smaller?
2.
So I switch them, 2 and 3. So yeah, so this is why this is not very efficient, because I might end up switching the same numbers over and over and over again until I get them all in the right spot.
Yeah, I was looking at positioning and not actually switching, and maybe it was just the numbers.
Yeah.
Instead of switching spots, I was looking at this is position, and now it's switching positions.
Okay. Chris.
This is a bubble sort.
This is not a bubble sort.
What is this one called?
That's a good question. I don't know. What's a bubble sort? A bubble sort is a much more efficient kind of sort. Basically, with a bubble sort, what you do is I think, I'd have to go back and check, you split the list into several chunks, and you sort each chunk at a time, and so the top number, and then you sort all the top numbers and sort all the bottom numbers, and it's much more efficient. Because basically what's happening is, we're going to have to compare every position with every position every time. That's a lot of checking if your list is long. It's very inefficient. But it's the easiest one to code, and that's why we do this one first. Okay, so to do this, I'm going to need, I think, a for loop, and an if loop, an if statement, and then another for loop. So I'm going to need one for loop to tell me what spot am I currently checking. Am I checking the first spot, the second spot, the third spot, so on and so forth. And then I'm going to need a second loop to tell me, all right, if I'm checking the first spot, compare it with the second spot, compare it with the third spot, compare it with the fourth, compare it with the fifth. So we're going to need nested loops, and we're going to need an if to check. And then we'll need to see how we switch the numbers. All right, so we're going to make a new function that does that. So what kind of function will this be? Void, int, double, character. Void? Why void? Because we're sending it an array, we're changing the array, and the array is coming back to the main. So we're not sending a single value back, we're sending an array back. Arrays are always reference variables. So it has to be a void. I'm not sending back a single number or a single letter. So it's a void function again. I'm going to call it sort, I guess, because it's going to sort our array. Int Ray. Let's call it Ray, I guess. Ray Charles. No, just Ray. Do I need the brackets on that? Which brackets? The square ones? Yes, I need the square ones because what am I sending it? An array. So I need to tell it I'm sending an array, not just a single integer value. Again, putting a number here is optional. I'm not going to do that. Typically you don't, because then later on if you decide you want to change this to 10, you don't have to go back and change all these too at the same time. Let's do it once. All right, so we have a new void function. Void sort int array. All right, so we said we're going to need 2 for loops. So I'm going to do for int position equals 0. So this loop position is going to be the position that I'm currently trying to find. Like if I'm trying to find the smallest number, that would be position 0. If I'm trying to find the next smallest number, that would be position 1, position 2. So position is the one I'm testing. I want to see what do I need to move into that position, find the smallest number left and move it into that position. So position starts at 0. Where does position end? Less than 5? Okay. Position plus plus. Then I need another for loop. So this is going to be this for loop. This is going to be, I'm starting here, I'm trying to find the smallest number here, so this one's position. What do we want to call the other for loop? Well, what I'm going to have to do, of course, I'm going to have to, for position, I'm going to have to compare it to this one, this one, this one, and that one. So I just need a name for it. Index. I was going to go with check. I'm going to check to see if this one is smaller or not. So if position starts at 0, where does check start? Position 1. When position later on, when I'm down here, and position is at spot 0, 1, 2, where does check start? At 3. So check always starts at position plus 1. Always starts one spot to the right of where we're checking our position for. All right, so int check equals position plus 1. It always starts 1 to the right. And check will end at 5. Check plus plus. Okay, so there's my 2 for loops. Now we need an if. If ray at brackets. If ray where? If ray at position is spelled correctly, greater than, the way he's doing it, ray at check. Because what he's saying is this is position, this is check. So if position is bigger than this one, that's when we need to switch. So if you did it the other way, you could have gone ray at check less than ray at position. Same thing. So the way we wrote it, if this one is bigger than that one, we need to switch. All right, so how do I tell it to switch the 2 numbers? Yeah, I'm going to need a temporary variable to store one of the values, and then I'll switch them and then put the temporary one into the... Okay, so we're going to need a temporary variable. Int temp. I like temp just for a temporary variable. All right, so we save one of them. Temp equals, which one do you want to switch? Or which one do you want to save, I mean? Ray at check. It does not matter in any way, shape, or form as long as you do the next 2 lines correctly.
Check.
And then we're going to take ray at check and turn it into ray at position. So this is why we needed to save ray at check temporarily, because we're about to erase it and write over it. So we take ray at check and we store ray at position. And then finally, array at position becomes what? The temp number that we stored to save it so that we could just switch the variables. So there's how you switch two variables. You have to have a temp. Save one, switch one, and then finally switch the second one back. All right, well, let's try it. That's our whole function. How in the main do we tell the computer, hey, I want to sort my array? Sort values. And then I can output the values. So that was handy that we wrote that little output function, because then we needed it a third time. All right. Convenient. Like I knew. Ah, very good. What is this going to sort? It's going to sort the double values because of where I put it in the code, isn't it? Is that what we want, or do we want to sort the original? It doesn't matter. It should sort either one of them.
You should run the sort thing twice.
Yeah, see, if I take the sort thing,
If you do it first, then it's already going to be sorted.
right, if I put the sort up here and output it, then it's already going to be sorted, and when I double it, it's going to double all the sorted answers too.
Well, then yeah, put it up there.
Put it up there? You'd rather sort it before we double it? You guess? That's what you told me to do. So.
Then both of them will be sorted.
Then both of them will be sorted. That is correct.
Yeah, you don't.
Yeah, I do. This outputs the original.
So it wants the original sorted.
So this one's going to output the original.
And then it's going to sort.
We're going to sort the original, then we're going to output the new sorted one. Then we're going to double the sorted one, which still has the original numbers, just in a different order. And then finally we'll output the double one. All right, need 5 numbers. 8, 7, 5, 3, 9, just to switch things in order so they're not always decreasing. Yeah, but that's kind of, well, I guess 9's already the biggest number. It's going to end up at, all right, let's see. So it prints the original, 8, 7, 5, 3, 9. It sorted them, 3, 5, 7, 8, 9. Put them in order, and then it doubled them, 3, 10, 14, 16, 18. Questions on that? All right, the last thing to talk about a little bit today two-dimensional arrays. What's a two-dimensional array? It's an array of an array. In a math class, we would call a two-dimensional array a matrix. So we might, in a math class, write something like this: 1, 3, 5, 0, 2, negative 1. I'll just leave it like that, I suppose. So there's a two-dimensional array. In this array, we would say the size of this array, this is, how big is this array? This is a 2 by 3 array. What do you mean by 2 by 3? Well, what the 2 really mean, yeah, because I wasn't thinking. I was going to make it 3 by 3, but then I wanted it to be different, so the indices were different. Is 2 down, 2 rows, and 3 columns. So when you define an array in C++, you define it in that order. First you say how many rows it's going to have, and then you say how many columns it's going to have. And again, it's a little bit confusing because in math, when we write a matrix, this position we would usually call A11, this one we would call A12, And this one we would call A13 if we were going to have three things across. Unfortunately, in C++, we don't do that. What do? We start at 0, so this one's A00. The upper left-hand corner is the spot A00. What's the next one? A01 and A02. So same deal with a 2x2 matrix. Indices always start at 0 still. So this next one would be A10, A11, and A12. So for somebody who teaches math and then does computer programming, I get confused. I mess up my indices all the time because I do a lot more math than I do computer programming. So I always think of the math format. And then basically what I'm doing is I'm chopping off a whole row and whole column of my matrix, and I only deal with part of it, and I forget. And then I don't get the right answers, and then I realize, oh crap, I did it again. All right, so assume you have a two-dimensional array. Write code that will find the largest value in the first column. So the first column would be up and down. Up and down. It's 5 by 5 though. So how would you find the first value, the largest value in the first column? We're definitely going to need a for loop because we have a 5 by 5. We're going to want to go all the way down the first column. So we're going to need to test 5 things. So we're going to need a for loop. So we're going to make a variable, and we're going to make it equal to the first value.
Then we're going to test it.
And then we'll test it each time, and if it's smaller, we'll flip it. All right. I think we'll just write that by hand here. So we have an array. What kind of array did we make? I guess it'll be an int. And to be lazy, we're going to call it A. Although I know you would never do that. You would never call a variable a single letter. You wouldn't do that. So we're going to need a for loop. Well, first, I think we said we need another variable, int, I'll call it min, equals, and I want to initialize that to the very first thing. So what's the very first thing? A at 0, 0. So we start by saying, well, the minimum's the very first thing. Start with that. Then we need a for loop. For int loop equals, loop starts at 0? 0?
Yeah, sure.
No, we already started.
It would not be wrong to start it at 0, but we've already taken care of the 0 spot, so we might as well start it at 1. We'd be testing it against itself. Wouldn't do us any good. So we might as well start at 1. Loop ends at? I've heard 4, I've heard less than or equal to 5, and less than or equal to 6. Less than or equal to 4, because if this is a 5 by 5 matrix, it's going to go 0, 1, 2, 3, 4. That's going to be our 5 spots. So it's either less than or equal to 4 or less than 5. Loop plus plus. All right, then what do we need to happen inside our loop? An if. If what? Just 0 there? Is that what you wanted there?
Oh no, if min. You can do it for that. So yeah. So if min is
If, okay. If min A at 0, loop. Because we said we're always going to stick in the first column. In the first column, the first coordinate is always 0. So I don't ever need to change the first column, the first coordinate, only the second one. So if min is less than the spot we're checking, then save it, right? Oops, that's going to go in there, bracket. Min equals a at 0. All right, and I think that's what we need. I think that's code that would run down the first column, finding the minimum, finding the smallest value.
We want the large B.
Oh, we wanted largest.
Same thing,
So we
except
just
say,
put the less than or
yeah.
And call it max instead of min.
I mean, you can call it min if you want.
We can call it min, but that would be silly. All right, so yeah, I didn't read the directions very clear. We wanted the maximum value. The only thing that you really need to change is that. And then calling it min is kind of silly, but too late. We already did. All right, calculate the sum of each column of A, and then store that into a one-dimensional array of size 5. All right, so here's what I'm saying. Let's say we have a 5 by 5 thing. And it's got a bunch of numbers in it. So what I'm saying is I want you to add all the numbers in the first column and then store them into an array. Then add all the numbers in the second column and store that to a spot. All the numbers in the third column, so on and so forth. So we're going to add all of these and store them into a new one-dimensional array. And then we're going to take all of these numbers, store them into the second spot in a one-dimensional array. So on and so forth. So we'll have to do that 1, 2, 3, 4, 5 times. No, we only need to declare one new array. It's a single 5-dimensional array. So I'm going to add these numbers and store them into the first spot of the new array. Add these numbers, store them into the second spot of the new array, so on and so forth. Okay, so we're going to have our first int array here. And then we're going to need a new array, and it said in the directions to call it B. And that's just going to be a one-dimensional array that allows us to store our values. Okay, so how am I going to tell it? First add up these numbers and store it. Then add up those numbers, store it. I'm going to need a nested for loop. I'm going to need a for loop to tell it, start here, and then a second for loop to add all those numbers. And then the for loop needs to move to here, add all those numbers. So again, nested for loops. When you have two-dimensional arrays, you make lots and lots and lots of nested for loops. Just because you're always accessing across or down or whatever. All right, so we need a for loop for int. What do we want to call it? I think I would call it column because I first want to deal in the first column and then add up everything down the rows. So outside I think I want column. So int column equals 0, column less than 5, column plus plus. So that tells me start in a column. Then I need a for loop to go into a row. For int row equals 0, row less than 5, row plus plus. Then what do I need to do? So I'm starting here. I've got a for loop that's going to count me through these 5 things. I need to add them up, which means I need another variable to do a sum, don't I? And I better initialize it at 0. So I need an int sum equals 0. So I think all I want inside this for loop is sum equals sum plus a at column row or row column? Rows go first, columns go second. So remember, we're going to start here. This is position 0, 0. We're going to add to it position 1, 0, position 2, 0, position 3, 0. All right, so that's why it's helpful to always call your variables row and column. Row always comes first, column always comes second.
Can you plus equal here?
Yes, I could plus equals.
The first one that we did for the 5 by 5, what the variable used in the loop be in the first square brackets and the second?
Well, I can put them wherever I want. But remember, what I want to do is I want to add all the numbers in this column.
Well, no, for this if statement here, because we have it, the first loop that we did.
This first loop?
No, up here. We have it at 0. What of that for just for the first row? Because we have it at 0.
All right. See, this is why you should use row and column in that loop. What he's saying is teacher screwed up this one. This one should be loop 0. Absolutely. This column is never changing. It's the row that's changing. Absolutely. Thank you. It should be that way. Absolutely. And then same thing down here, right? What we just did is we found the maximum of the first row, not the first column. Column's not changing here, it's the row that is. Thank you. Very good. All right, anyway. This adds them up. Once we've added them all up, what do we want to do?
Store them.
Store that. So where am I going to store it?
B5.
B column equals sum. And then there's one more thing that a lot of people will forget to do the first time. Before the loop goes back, reset your sum to 0. Otherwise, when the loop goes back, it's just going to keep adding more numbers to the answer it already has. That's an easy thing to forget. Reinitialize your sum. All right, so there's a little program. Well, not a complete program, a little block of code that would add up all the columns and store it in a single array. To a single array.